This is the woodshop I built into my garage, engineered the same way I build systems at Google. 20 years building things like Gmail and Android taught me how to design a system, so I built all 7 systems in here the same way. Plus, one more I've never seen in anyone else's shop. Each one runs on its own engineering principle, and I'll be explaining these as we go. Most of it I'd build again exactly like this, but the handful of things I'd change all came down to the same blind spot. See if you can spot the pattern. Principle number 1, build it to be changed. Get this wrong, and the day you move one tool, you'll be tearing open every wall that you just closed up. I'm a software and mechanical engineer, and you'll be seeing both halves of that show up all over the shop. So let's get started with the electrical. All right, let's talk about the electrical. So I have this sub panel here with the electrical for almost everything in the shop. So all the electrical is running out of EMT. I prefer the EMT because it's just wires and you can easily change things. For example, if you reorganize your shop, you can have the 240 circuits be in one place and then you can move it to another place without having to reopen the walls. Yeah, and I actually did redo the shop when I successfully took over the wall that had a bunch of bikes on it and turned it into where the table saw is. I rewired the shop and I added extra lines for the table saw, which is over there, and for 120 volt outlets. The 240 outlets in the shop are connected on this one circuit breaker because I never run more than one at a time, except for the dust collector that has its own circuit, and that's in the main panel, not in this sub panel. And then I have a circuit for the lights, and then I have a couple different 20 volt circuits. So we did the electrical for the dust collector and the air compressor behind the walls instead of in the EMT when the walls were open. And then we added the EMT on top later. So that's why those are in the main panel. For all of my 240 volt outlets, I use these twist plugs so that they stay on there. You just have to replace whatever is on the end of the cord that comes with the machine with one of these. You just get it at Home Depot, put it on there and twist it on, and then it doesn't come off. So the first thing I thought about when I got serious about doing woodworking in my garage in 2022 was to set up electrical. And if you've had the opportunity to set up a new shop while the walls are still gone, you've probably thought that you want to wire everywhere with 120 and 240 so that you'd have a spot to plug in all of your tools. But the real cost when wiring the shop isn't the first job, it's all the ones after that. Because if you cover up all the wiring in your shop based on a plan that the table saw is going to be in the middle of the room, but then you get some more space like I did, you're going to be tearing open the walls to run electrical to the new area. So the first engineering principle here is build it to be changed. So despite the fact that I opened up the walls to put in insulation anyway, I chose not to run the electrical through the walls, and I specifically chose to run the electrical through EMT conduit on the surface of the walls after I put up the wood paneling. And I did that for a specific reason, which was to have the ability to easily change the electrical. And I've taken advantage of that several times in the shop already. And we do this in software engineering all the time as well. The first version of the code that you write is only version 0. If you make the architecture super brittle, then it'll be hard to change anything. And your customers are definitely going to want you to change things. So if it makes sense, we always design the software so that it'll be easy to change in the future. And so let's move on to the second principle, which is to name the real problem. Miss it and you'll keep buying brighter and brighter lights without ever actually solving your problems. So to set the stage, after I added the electrical in 2022, everything was great for actually using tools that I had, unless I actually needed to be able to see anything, especially at night. So I added lighting. And by the way, I'm moving through these systems pretty quickly, so if you have any questions about details, then just leave them down in the comments. Let's talk about the lighting. I have a bunch of lights on the ceiling. They're very bright. I can see pretty much everything. We put the lights in ourselves before we insulated the ceiling. We did not go in the attic to do it. We actually ran the wires from down here. We drilled the holes on layout, and then we fished the wires, the Romex, from light to light. The lights are turned on and off through here. This is a fake switch. This is a Lutron Pico switch that's not actually connected to anything. So the actual switch for the light is currently located on the ceiling. And there's a dry contact relay inside that box that's connected to the switch. And so it goes through automation to be able to turn it on and off. But since we're selling the house, the automation is no longer in existence. So instead I have this switch, which is a stick. So I can just get up there and turn the lights on and off with the stick. But I'm gonna move the switch over to here after I take out this lumber rack and the wall. Also, the electrical does run on a conduit back into the wall that's in front of the garage door. And then it changes over to Romex inside the wall. And then that's just powering these outlets here. So these outlets are in the temporary wall, so they'll come out when we tear down the wall. So another thing that I have is I have a couple of these emergency lights set up so that if the power goes out that I can still see. So even in the middle of the day, it's pretty dark in here. I've actually seen people on Instagram who are like, oh no, the power went out and now I'm lost. And it was like really scary in my shop. So I have this stuff like here, so this light will turn on automatically if the power goes out. And your eyes actually take a little while to adjust, but if you stay still for like a minute, at least you'll be able to see instead of not see anything at all. Because it can be pretty scary, I would say, depending on what you're doing. And then even though these lights are very bright, if you're like working on walnut or something, and like you're trying to cut lines to a dovetail to a line or something like that, I can't see it that well, and there's like shadows from whatever. So I just have this lamp. This is from IKEA. Turn that on, and then everything's very bright. I can move this around, and then I can also move this around. So say I want it over here, or I want to get it out of the way. That's really easy. And then all this is a thing that I just made a 3D print of, where there's a 20 millimeter, well, it's for a 20 millimeter hole, slightly smaller than 20 millimeter nub sticking out the bottom. And then I found an existing design that was already sized right for whatever this was. And so I just modified that to have this down here. So I think I had to print it with like more infill than normal, like the typical settings, but it works really well. That can just go in there, and then you can just stick it in whatever hole you want. So those super bright ceiling lights make the whole shop visible, and it was like really a great thing that I could see. And these high CRI Keystone LED lights are really great, by the way. And for a while I thought that the problem was solved, but I kept having to add more lights, the emergency lights and then the lamp at the desk. And looking back, I realized that I didn't have one lighting problem, I actually had three. Seeing in the room, seeing when the power goes out, and seeing fine details on wood, especially dark wood. The solutions to all three of these problems are called lighting, but they're not the same problem. So if you try to solve them the same way, you won't actually solve it. Adding more light doesn't help when there's a blackout, and it doesn't help you see the details when you're up close, especially if your head is making a shadow on the wood. Bright isn't the same as visible. So the principle is name the real problem. Lump all three problems under the same word and you won't actually solve 2 out of the 3. It was at this point that I got a table saw, and in order to get it up and running, I had to get dust collection working. And that brings us into principle number 3, build for your everyday. Because one lazy choice can cost you 20 seconds every time you need to cut a piece of wood, and that can really add up over the years. Let's talk about dust collection. I have an Oneida Supercell. It's a high volume and high pressure dust collector. It's on a 20 amp circuit, and it has a remote, and it drains down into this barrel that I actually have never replaced the bag on. You can just take the bag out and dump the bag into your compost and then put the bag back in. I always wear a real dust mask when I do that. So the inlet to the dust collector is right here, and it goes into the ceiling, and that goes out to the rest of the shop, out through the top of the closet. You need to be able to access this top, so you can take this black part off and access the filter inside. And I thought, based off reading the instruction manual, that I would have to be able to go higher than the height of this closet, but that is not the case. But I didn't know that till I already installed it. So there's a panel here that opens up that goes to the roof of the closet so that this could go up higher, but you don't actually have to use it. And so this comes with the red light that blinks when the thing is full. So there's a sensor on this barrel. And then in order to get that light out, I just have this data cable. Like I just bought whatever this is, like 18 gauge wire, and it just kind of runs up through here and out the front of the closet. On the outside of the closet, you can see right here where the light comes out just through there. I just used a long drill bit and just drilled through the drywall and through the siding. Careful to avoid a stud. And then you can see up here where the pipe came out of the ceiling of the closet. So it goes up here. And then I have like different Ys and angles and whatnot. And then I have like it set up for extension. I mean, I won't be extending it, but if I ever did extend it, I can just continue that run right there. So I have those panels or whatever, little shelves that I put up that would support the weight of the pipe without having to do a bunch of straps. And I just made those by gluing and nailing together some of the scrap from the wall siding. For the blast gates, I have these that I built based off the J-Cat's Moses design. And they work really well. And also I have the manifold here. So there's a blast gate that grants access to the manifold, and then the manifold lets you switch. Let's take that off for a second. The manifold lets you switch between these 3 different pipes. So you can switch which tool you're going to. So these tools, I'm also using the Rockler dust rate collector, like whatever this thing's called. So I can hook it onto like the planer like that, or switch it over to the drum sander. But then I have one label here that says jointer. The other labels are missing. And then one of them goes to a floor sweep that I built. But it does not work very well. I would not build it in that shape. So I just put marker on these blast gates, like red and green. So like if you can see a bunch of red, that means it's closed. And then if you can't see red, then that means it's open. And then over on this side, it's very green. So you can tell that it's open. And then if all you can see is a little nub of red, which you can't see on this one, but on some of the other ones you can see. You can tell if it's open or closed. And these work very well. And I mean, it's not automated. It would be better if it was automated. But as far as manual ones go, it's definitely way better than the aluminum ones I've used. And they didn't take that long to build. Especially if you're batching them out, you can get them done in like an hour or something like that. One thing that's really annoying is that this one for the table saw is on the wrong side of the table saw. So if I'm actually like go over there to close a gate for like the jointer, and then I want to turn it on for the table saw, I have to come over here, but there's really no other reason to be over here. So it would be way more convenient if the blast gate was over there. So even though the piping would have been more annoying if I did it that way, I would probably change that so that it's easy to get to the blast gate for the tool and use the tool at like the same time.
But you already had all the garage door. The garage door and the lights, that's why you
Yeah, but I could have come, so I couldn't have gone like move this Y down further, because then it couldn't go through the lights and the garage door opener rail thingy. But I could have had it come over here and turn down that way or something, and then turn again. I don't know. It would have been very annoying, but I think it would have been worth it for how much more annoying it was to have to go over to the blast gate over here all the time. So I'm using 4-inch PVC. I think that is working really well with the supercell. It's because it's high pressure. Also, I'm using a lot of the flex hose. This is like the super sturdy flex hose that comes with the supercell. I don't know if they even still sell it, but it came with the supercell. It's like very sturdy. But if you look at this flex hose, it's much not sturdy. It's squeezier. So that actually is really easy when it's on this one to move it around. But it also like compresses a lot when the pressure is when the air is being sucked in. It like compresses the hose and can be kind of weird and annoying. Whereas the one that's more sturdy is good. But it's much cheaper and it's good enough. So I would probably keep the cheaper hose. That's just off Amazon. So in addition to the dust collector, we also get dust in the air anyway, especially if you're using like a handheld router or something like that. So on the ceiling, I have the dust filter. It's like Jet AFS 1000B, I believe. And I have a remote that lets me work that from the ground. And it also has a timer on there, so I can just leave it running. And then on the wall over here, I have this air quality monitor that just checks the air quality, and it's just always on, and I can see it across the shop. I can see that number and I can see the color. So whenever it's bad, then I know that I have to turn on the air filter. But I prefer it to be off so that it's quieter. And usually if I'm using like something with the dust collector or the dust extractor, I never need to use the dust filter. I only turn that on when I need to. So that system works really well. The Supercell is really great. The blast gates that I made work way better than the ones that I could buy at the store. And I can switch between the tools without having to drag a hose around. But there's one thing that's super annoying anytime I have to mill up some lumber, and that is going to open the blast gate or close it for the table saw. To open it, I have to walk around to the other side of the table saw when there's no other reason for me to be over there. And here's why that happened. When I built the system, I optimized for how easy it was going to be to run the pipes across the ceiling, especially around the garage door opener and the lights. What I didn't optimize for was having to go actually change the blast gate whenever I needed to use the saw. I built the system once, and that took like an hour, but I have to walk over to the other side of the table saw every time I want to use it. And that's the principle, build for your everyday. The cost isn't paid when you build the system, it's paid every time you use it. And this is really common in software engineering too. You only write the code once, hopefully, but you'll be reading and modifying that code along with all of your coworkers and everyone who works on that code long after you're gone for years to come, hundreds of times. So we optimize our code not to be easy to write, but actually easy to read. In fact, we have a system called readability review where you have to pass this readability review to make sure the code is readable before you can submit it. So yeah, in the next shop, the blast gate will be on the other side of the saw. And that next shop is coming soon because we're moving, so get subscribed so you don't miss it. So now we move on to principle number 4, which is to solve the whole equation. If you only look at half the problem, you can spend thousands trying to fix it and never actually solve anything. Okay, let's talk about my favorite part, the climate control. So I'm using a Mr. Cool mini split. It works fine, I installed everything myself. We did the electrical inside the wall. That's a 30 amp circuit. This is the 18,000 BTU mini split. But the mini split on its own is actually not very useful. The most important thing is the insulation. So when I first started woodworking in this shop, it was really hot, even here in Seattle. In the summers it gets really hot. Definitely too hot for me to actually enjoy anything. So we needed to get the mini split, and I knew that we would need insulation because I don't want to like waste a ton of money and not have it actually work. Actually, I remember the first winter as well, it gets cold here, relatively speaking. I was doing finishing on my first project that was like big. And I remember being out here in the freezing cold at like 11 p.m., putting another coat of poly on the thing. And it would just like take 24 hours to dry because it was so cold. And it was miserable, and it was dark because I didn't have the lighting. And that's when I was like, I really need to like increase the infrastructure in this place. So one of the first things we did basically the next summer was insulate the walls. We cut the drywall off of all of the walls that don't share a wall with the house, and we just put insulation in there. We used rock wool insulation. It's 2x6 studs on these walls, so we're using that thicker insulation. I remember when we got all the insulation up and all the bays were open and you could see it, and then it was just like quiet. So that's like another thing. There's a pretty loud highway noise out this back wall that goes towards the freeway over here. And I didn't even realize how loud it was until we put up all the insulation, and it was just like, and like if you put your ear right up against the insulation, it was like that ear like heard nothing, and the ear facing towards like the empty garage was like loud. Is crazy. But yeah, so we put the insulation all through this wall here. Like you can see where the drywall was cut. So I cut it so that these 8-foot tall siding panels, T111, would fit exactly under there. being level. So the garage floor is sloped, of course, so I had to make sure that the top one was level and that at the point where it would be hardest for it to fit, that it would fit, which would be towards this side away from the door. We fastened them actually with these trim screws, so you actually can't really even see these trim screws, but I believe there are 5 or 6 at each stud. And then in the ceiling, we cut a big hole in the ceiling that's mostly covered up now. I mean, you can kind of still see where it was. My wife climbed up there and blew in the insulation. So we rented the blow-in insulation machine from Lowe's and bought a bunch of stuff and brought it home in the minivan that we had at the time. And then she went up there and traipsed about and blew all the insulation in. And you love that, right?
No, it's horrible.
It was horrible? Oh. Also, while she was up there, she stapled some of the Romex for these lights so that people don't trip over it. Also, on this part of the wall, so the interior of the house is on this wall, but it doesn't start until like about right here. So that part of this wall is exterior, but you can't remove the drywall that separates the garage from the house. This is a fire code. So this, if you look at it, this paneling is actually proud of the drywall, unlike over there where it's flush. So for this part, I opened up the drywall right here in like a square-ish shape and then shoved the insulation up and down and then like patched the drywall underneath this wood just so that it was good, and then put the wood over top of the drywall. There's some spots where we didn't get the insulation. Like we didn't like open up here because there's gonna be like a giant header above that window. So it's not like worth it to deal with all that to like get a little bit more insulation. And so we also didn't like open up in that crevice up there just because I didn't think it was worth it. So that part's not really insulated. Although like some of those, like the ceiling is insulated up there. But if you look at it with a thermal camera, you can tell that that part's not insulated.
How long's that big crack been there?
Probably since we put it there.
We did it?
Yeah. Also, I didn't want to mess with the drywall all around the electrical panel that's underneath this flag. So the siding's proud of the drywall here as well. So there's just like a hard transition right here where it comes out, but you never notice it unless you like walk over there and look at it. Yeah, everybody forgot about that. The mini split and the insulation work really well together. If you come out here, the temperature is always perfect. It doesn't get extreme temperatures here in Seattle. It only will go like down into the 20s. We're up very occasionally into the upper 90s, but usually like in the 80s in the summer. And the summer is only like 2 months long here. But it's never uncomfortable in here. And like it's very stable, so the wood doesn't move around like in storage. It's just all acclimated. And even though it rains a lot here, it's not very humid. I don't think, at least not indoors. So like in here, it just basically stays 50% humidity all the time indoors. So we don't have to worry about that. And it's like basically the same humidity in here as in the house. Another part of the climate control is this fan that I think I got on Amazon that's just hanging from the wall there. And it blows across the whole assembly, like where I do most of my work. It doesn't like get me over by the table saw, but you don't spend that much time over there. You can suffer through, but yeah, whenever I like get moving, hauling around wood and walking around a lot, then I'll be sweating and fog up my glasses. But if I have that fan on, it kind of keeps everything nice. So now the shop is comfortable to work in year round. And the easy thing to point out would be the mini split. But the mini split is really only half of the solution. Without the other half, the mini split would be a useless money pit. Because heating an uninsulated garage is just paying to heat the whole neighborhood. The thing that actually makes it work is the insulation. And that's the principle, solve the whole equation. My goal was a comfortable shop, but there was a hidden constraint hiding behind it. It couldn't cost a fortune to run. The mini split hits the goal, but it doesn't solve for the constraint. The insulation is what makes it possible. And that's the heart of engineering. In tech, we run week-long hackathons where small teams get to turn their pet projects into reality. But all they have to do is create a demo. And a surprising number of products that you use every day actually started this way. But turning one of those proofs of concept into a real product that billions of people can use can take years for large teams. And almost all of that work goes into solving the constraints that the demo got to ignore. The mini split is like the demo. Meeting the constraint, keeping it cheap to run, is what made it into an actual solution. Moving on to our fifth principle, hand off the work, not the judgment. Outsource one job without thinking it through and you'll be living with the consequences every day. So to set the stage, every system we've talked about so far I've built myself. But for the flooring, I decided to hire it out. Let me show you how it turned out. All right, let's talk about the floors. So for the floors, I went with epoxy with some flakes here. It's like a light blue gray. It's definitely preferable to just having the regular concrete. That was like very hard to keep clean. It was very uncomfortable to walk on. I don't know how much better this is, but it seems like a little bit better. But this is definitely way easier to keep clean. And so like if you drop like some finish or oil or whatever on the floor, you don't have to like worry about it. You can just like easily clean it up. It doesn't stain. These flecks that are in it provide some grippiness so you don't slip. But you want to make sure that they do a good job on that because there's some spots of the floor where the top coat that goes over top of the flakes that's clear kind of like covered the flakes. So it's like slippery in some spots. I think like over the years it's worn down a little, so I haven't like slipped, or maybe it's just the dust everywhere. Another thing about these floors that I don't like is that the color of the floor is, or at least some of the specs, is suspiciously similar to the color of regular like metal colored screws. So if you drop a screw or a washer that's like the chrome color, it can be really hard to find. I have to bring my wife in here to find them. Or I have to get like the metal, this thingy that I can run across the floor in hopes of finding it. But I'm pretty sure I've lost a lot of those to the vacuum or to the broom, even though I try to check before I throw it in the trash. Another thing that makes it hard to clean is the expansion joints that are in the concrete. So I believe that when you get the floors done, that you can ask them to fill that up with like a flexible thing, and then when you epoxy over it, it still works to prevent cracks outside of the joint in the concrete, but then you end up with a smooth floor. But as it is, a bunch of stuff collects in there. You basically don't get it with a broom. You have to come through with a vacuum. So that's kind of annoying if you're trying to keep the dust down. One other thing is, you can see on the floor I have this little square taped off with blue tape. That was actually my youngest son's little workshop area that he had like his play workshop in, and he would come in and he had like a real hammer and nails, and he just like hammer it or like play with different stuff in there. But eventually he stopped coming in here to use it, so he got evicted. So the epoxy floor is great. It's way better than the bare concrete. It's easy to clean and it doesn't stain. But there's a couple bad parts. It's really hard to see screws that fall on the ground, and you can't sweep out the cracks. None of that is the floor guy's fault though. I asked for a durable floor that looks great, and that's exactly what I got. I never said pick the color that hides the hardware or fill the joints. Those were my calls to make, and I didn't make them. In fact, I picked the color without even thinking about screws. That's the principle. Hand off the work, not the judgment. You can outsource the labor, but if you skip making the decisions, then someone else will make them for you. They're probably going to make a decision that makes it easy for them, not for you. This is the same as handing a spec to a different team. You get what was written down, not what was in your head. And it's also important to research the whole thing as if you were going to do it yourself. That's the only way that you can know what to actually ask for. But sometimes even when you think you thought it all through, you still miss stuff. And that's our sixth principle, trace every consequence. Because if you don't think through the side effects of your solution, you might have had no solution at all. All right, so now for the part that I haven't seen anyone else do, is create a sound closet. So this is my closet. And inside here is a lot of stuff. The reason I built this closet though is to keep the sound from the air compressor and the dust collector inside. So I built the walls out of staggered 2x6s. So every 8 inches there's a stud in this wall but every other stud is on either side of this wall. So like one stud will be on this side of the wall, and then the next stud will be on this side of the wall. So from this side, they're 16 inches on center, and on this side, they're 16 inches on center. But if you looked at it from like far away, it looks like they're 8 inches on center. So there's a break. There's no physical connection through the wall, like of lumber. Inside this wall is safe and sound rock wool insulation, and it goes like weaves through the studs. So there's a continuous layer of rock wool that goes through this wall. And then also in the ceiling is rock wool insulation. It's a 2x4 ceiling. It's only 4 foot deep from the outside of the wall of the closet to the back, and there's a ledger board that just goes across the top. So the other thing I did is I put this exhaust thing here, so I just have a hole in the drywall, and this is just like a regular air return vent that you can get at Home Depot, and that goes up, and then it actually like mazes through in the ceiling. And then out the top, there's like another one of these vents on the back. The reason why I did that is because this is the dust collector. So when you're sucking in a bunch of air into this dust collector, like 1,000 CFM, it comes out the top, and then that needs to get out. So it's either gonna go out through the door, or it's gonna go out through the vent I made. So the idea was to make it so that the door could be closed and that I could have the door basically be airtight. And then most of the air could go out there. But in reality, there was a different problem that I didn't account for, which was the temperature. So I have this thermometer in here, so the dust collector hasn't been running. So it's basically the same temperature in here as it is in the main part of the shop. So when this door is closed, even without me like sealing up the bottom, there's like an inch gap at the bottom. Even without fixing that gap, when this has been running for like 20 minutes, it's like 90 degrees in this closet. So I never sealed up that gap because I don't know like how hot it would get, and I don't know like to what extent this thing can operate when it gets really warm in here. Like I assume it can work, and like if it was like 100-degree shop, it should still work, but it's probably not like good for it. So I just left it that way, but the sound reduction is still really nice. Like it's perfectly fine. And it's definitely very noticeable when I forget to close the door. That is like really important to me to have that sound go down. So I'm very sensitive to loud sounds, and I really don't want to wear ear protection all the time. So even just having this air compressor go off every once in a while is like very jarring to me. I do not like it. If I can hear it like in the same room. And this is like a quiet one, like a California Air Tools quiet air compressor. It's very noticeable when the door is open just from that, let alone this giant dust collector. With this dust collector on with the door closed, it's actually quieter than using my CT26 dust extractor just at full power, like right next to me. So I can be like all the way on the other side of the shop and have that on, and it is louder than having this giant one on inside here with the door closed. And I would definitely do this again. I also have like all this shelving in here. It's very convenient to kind of like have this away. There's just like a bunch of random stuff. I have like all my batteries here. I printed like these holders so you can just like store the battery on there, and that's nice. And then I have my different chargers for those. So it's convenient to have that in here instead of like having to build something out in the main area. So I fit a ton of stuff in here, including like a lot of stuff that's like harder to store in other areas. Like I have like my drywall T-square and levels and stuff. There's a 6-foot level. There's like a EMT bending bar, different stuff like that in here. That's just like super, it takes up like a lot of wall space if you just tried to put it all over the wall. But having like all these different vertical surfaces in here makes it really easy to store all that stuff. I wish I made it a little wider than 4 feet deep. I think I wanted to make it so I would only need 1 sheet of plywood on the ceiling, but I would rather have it be like extra 6 to 8 inches deeper inside of here so that it was easier to fit in this closet, or maybe have like slightly deeper shelves. But actually having like the not deep shelves is nice because then you don't end up hiding stuff behind other stuff. So maybe it's good. I just wish I had more room for myself. So I was actually diagnosed with autism this year, and one of the symptoms is that I'm very sensitive to sound. Too much noise and I can actually become super overwhelmed and emotional and need to lay in a dark room for hours. So this isn't a nice to have for me, it's a requirement in the shop. Of course I could wear big hearing protection earmuffs all the time, but those are actually uncomfortable for other reasons related to autism, so I like to use my AirPods as much as I can. And even when I'm not using a loud tool, when the air compressor turns on, that's pretty jarring anyway. But the closet sound reduction could be better if I thought through what else would change when I sealed up the room. Sealing in the sound also seals in the heat. And since running the dust collector for just 20 minutes makes it like 90 degrees in there, I never sealed up the door, and that means a lot more sound is leaking out of there than I originally intended. So that's the principle. Trace every consequence. Every change does more than the one thing you want, and the effect you don't trace is the one that bites you. Everything in engineering is a trade-off. So in the next shop, I'll build a baffled intake that forces cool air into the closet so I can seal it up and finally keep that sound out of my ear holes. And then finally we come to principle number 7. Don't build for yourself. It's the easiest mistake to make in your own shop. You build everything so that it fits perfectly for you and you never think about anyone else needing to use it. Okay, and here's the air compressor. So I have this California Air Tools 10-gallon air compressor. It's the quiet version. It's also aluminum, which is nice because the tank can't rust from the air, the condensate that builds up in there. So the air comes out of the compressor here and it just goes through this little whip that goes into a little port that's just sitting on the wall. And I have this valve here so I can isolate the compressor from the rest of the system. So I usually just leave that open. I'm just running PEX. I haven't had any issues in the past couple of years with it. It's not like rated to have this level of pressure in it. It's supposed to hold water at like 80 psi or whatever, not air at 100 psi. But I've read or heard that the main reason why it's not rated is because the PVC can break down when it's exposed to UV light. But there are almost no windows in this shop. There's just one window and it has a shade over it, and I'm in Seattle. So I don't think these lines ever get any direct sunlight. But you know, it could break. And that would be unfortunate. So coming out of this valve, it just goes up into the ceiling of the closet, and then it comes out of the top of the closet. And then I just have regular PEX mounting stuff. So there's like a T-junction there, and then I have the clips that can mount it to these blocks. And then it splits off around the shop. So I have a bunch of drops that come down, and then I just have a quick connect like this.
Got me. You got me.
But I mostly just leave those connected. And then almost all of the airlines are just connected on these from Harbor Freight. Everything here is Harbor Freight. So this thing is Harbor Freight, and then this is Harbor Freight as well. And then, yeah, like this reaches really far, so you can just basically get anywhere with this anyway. But I mean, if I'm over here, I don't want to have to go all the way over there to get air. So we got it everywhere, and you can just shoot it. And then I have one over here. There's a couple more there. And then there's this one, which I also use to...
You make them all really high, I can't reach them.
Yeah, they're too high.
They're too high for normal height people.
Not all of them. Look, this one's low. You can reach this one, see? Easy. Why is it tangled? Anyway, that's nice. And then I have this one. So I have this one on the Flexzilla reel on the ceiling. So I usually use this one when I'm using nail guns on these tables. So like if I'm like putting something together here, I have a nail gun on this, and then it's more convenient because you can like put the nail gun and there's like, you can put the nail gun down and there's nothing trying to like pull the nail gun off the table. So that's good. And then also I use this one when I want to fill the air in the tires in the car. So this one can reach out the garage door and to all 4 tires. So I would say if I was going to do this differently, I would probably have fewer of the drops and try to come up with a better way to deal with those blue cords. Or maybe it's just because it's a little too crowded in here for how many there are. I would put them lower so they're easier to reach. I don't know how much I like having this on the ceiling in the middle. It's kind of annoying. It's kind of annoying to have like a nail gun hanging right here. If you just want to put it away, you can like hit your head on it. But I definitely like having the air everywhere in the shop, and I would definitely use the PEX unless I was like, I don't know, making really long runs, or if there was a lot of open windows or like windows where sunlight can shine on the PEX, then I might want to use some of the more expensive stuff that has like an aluminum surrounding the plastic channel. But that's a lot more expensive, and I think it's a lot harder to put up. Also, I don't have an air dryer, and I don't have any air pressure regulators in any of the individual like drops. I just have it on the compressor itself, the regulator, and I don't have any dryer. Sometimes the air pressure that I have in the closet is too high for the tool I'm using, and I wish that I could lower it without having to go in the closet to turn down the pressure and then come back out and test it and like having to keep going back and forth. It would be a lot more convenient if there was a regulator closer. So having air everywhere is one of my favorite upgrades. There's always a hose just a few steps away, and using PEX made it cheap and easy. I'll definitely be doing this again. But I built every single one of these drops too tall for short people, which is anyone under 6'4". And I had no idea that they were up too high until my wife told me during the tour.
You didn't even know before that? I'm in there, I'm jumping, I'm trying to reach them all the time.
No, I had no idea. I thought they were good.
I have to get the steps still. I'm like, why do you keep them up so high?
I built the whole shop for me without even noticing. So the principle is, don't build for yourself. This is something we actively have to fight in software. It's super easy to make your app work really great for your team of tech bros. Building so that it works for everyone you want to help requires purposeful work. So in the next shop, the drops go lower so that everyone who needs to can reach them, not just me. Now, back at the start, I told you to look out for a pattern. Here it is. Every single thing I'd changed was the same mistake. I solved for the problem right in front of me and ignored the one next to it. I soundproofed the closet and forgot that it would trap heat. I picked a floor that looks great, but it hides every screw. I put air everywhere at exactly my own height. Different systems with the same blind spot. The hard part of building anything isn't the thing that you're staring at. It's remembering to look at all the things around it. None of these are deal breakers. I built a shop I love, almost all of it with my own hands, and my kids' and wife's hands. But that's the lesson I'm taking to the next build. You've just seen the air compressor in the sound closet, but what I didn't show you is that it's automated to turn on and off with my shop lights so that it's only running when I need it. But hook a compressor up to a regular switch and you risk destroying the motor. So check out this video right here where I'll show you how to automate yours safely.